single electrode potential and electromotive force. This is today's lesson. Let us see the matter in detail. Single electrode potential. Let us consider this is a vessel, glass vessel or ceramic vessel, in which solution of zinc sulfate has been taken. Solution of zinc sulfate. In this solution, metallic strip of zinc is partially submerged in the solution of zinc sulfate. This solution contains zinc 2 plus ion and sulfate ion. After the immersion of metallic strip of zinc in the zinc sulfate solution, a reaction occurs spontaneously. This reaction. Zinc atoms from the zinc strip go to the solution as zinc 2 plus ions. Leaving electrons in the strip. At the same time, zinc ions from the solution migrate to the metallic strip of zinc and change to zinc atoms. That is, here both the processes continue. Zinc atoms go to the solution as zinc 2 plus ions, giving up electrons, and zinc 2 plus ions deposit on the surface of the zinc strip, accepting electrons. Here both the processes continue, but rate of both the processes is not equal. But reversibility of both the processes exists. Here, tendency of zinc atom to form zinc 2 plus ion. This tendency is known as solution pressure. This tendency is known as solution pressure. Here, this is oxidation. So, we can say that this is oxidation potential. This tendency is known as oxidation potential, which is denoted by E zinc 2 plus ion. This is a phase boundary. So, zinc atom to zinc 2 plus ion. This tendency is oxidation potential of zinc. Now, tendency of zinc ion to form zinc atom. This tendency is known as osmotic pressure. Tendency of zinc ion to form zinc atom is known as osmotic pressure, which is reduction potential. Zinc ion to zinc atom receiving electrons is reduction. So this is reduction potential, which is denoted by this reduction, that is here, at a time, oxidation potential and reduction potential happen, but these two potentials are not equal. Due to the inequality of these two potentials, due to the unequal potentials, a potential difference or electrical pressure or electrical energy gets created at the junction of zinc strip and zinc solution, which is called single electrode potential. Single electrode potential. Due to the inequality of oxidation potential and reduction potential, a kind of potential difference or electrical energy or electrical pressure gets created at the junction between zinc strip and zinc solution. Electrical energy, which is called single electrode potential. Single electrode potential gets created due to the inequality of these two processes. Now, let us consider another vessel in which solution of copper sulfate has been taken, and in this solution metallic strip of copper is submerged partially. Then here basically this reaction occurs. Copper 2 plus ion changes to metallic copper, accepting electrons. At the same time, zinc atoms goes to solution as zinc 2 plus ions, giving up electrons here as well. Both the processes are not same, not equal. Here, this one, conversion of copper ion to metallic copper, which is osmotic pressure. This is actually reduction potential. This is reduction potential. At the same time, this one, solution pressure, which is actually oxidation potential. Here, these potentials are not same. Due to the inequality of these potentials, an electrical pressure is created at the junction of metallic strip of copper and copper solution, which is called electrical energy or single electrode potential. This electrical energy or electrical difference or electrical potential, which is created at the junction between metallic strip of copper and copper ion, which is called single electrode potential. But when these two electrodes are connected with wire, with a voltmeter or galvanometer, voltmeter is used to measure voltage of the cell. These two electrodes are connected with wire with a voltmeter, and here salt bridge is set. Now this is complete circuit in which zinc is more reactive than copper. So, zinc electrode will undergo oxidation, and here copper solution will experience reduction. That is, here we will see oxidation potential, and here we will see reduction potential. The sum of oxidation potential and reduction potential is called electromotive force. Electromotive force, which is denoted by E cell, electromotive force or cell voltage. This is also known as cell potential, which is denoted by E cell. E cell is equal to oxidation potential of anode plus reduction potential of cathode. The sum of oxidation potential of anode and reduction potential of cathode is known as EMF or electromotive force. When these two electrodes are connected with wire, in zinc electrode only oxidation occurs, and in copper electrode reduction occurs, because zinc is more reactive than copper. So the sum of oxidation potential of anode, this is anode because here oxidation occurs, and this is cathode because here basically reduction occurs. So the sum of oxidation potential of anode and the sum of reduction potential of cathode is known as electromotive force of this cell. Electromotive force, which is also called cell voltage. Here, when concentration of this solution is 1 molar and it is at 25 degrees Celsius temperature, this solution as well, concentration 1 molar and this is at 25 degrees Celsius temperature, then here oxidation potential, which is called standard oxidation potential. Standard oxidation potential is denoted by E0 or E theta. Oxidation potential will be standard oxidation potential when solution will be of 1 molar and temperature is 25 degrees Celsius. Then oxidation potential obtained is standard oxidation potential. Similarly, here when concentration of the solution is 1 molar and it is at 25 degrees Celsius temperature, then reduction potential will be standard reduction potential. This is reduction potential, standard reduction potential, and then we will get standard electromotive force of this cell, which is standard oxidation potential of anode plus standard reduction potential of cathode. So this is standard electromotive force and this one is simply electromotive force. Electromotive force at any condition, but this is electromotive force at standard condition. Standard condition, concentration will be of 1 molar and the system will be conducted at 25 degrees Celsius temperature. Then we will get standard electrode potential and standard cell potential, single electrode potential and electromotive force. Thank you for watching.